Hello student, my topic is today the line parameters and concept of transmission and distribution line. So today we will discuss what is a transmission line. As you know, to carry the current, it requires some conductor medium to transfer from one medium to another medium. So that is, we require a conductor for transfer of power and energy. That is known as transmission line. The medium which convert one substation to another substation or one generating station to another generating station, that is known as transmission line. So now I will discuss with the help of a schematic diagram. So here is my generating station. Consider it is a synchronous generator, synchronous induction generator. It works by induction principle for generating power. So this is my synchronous generator. Here we generate three-phase energy, that is three-phase power. So from here it will transfer to step-up transformer. This is my step-up transformer. From here, it will carry to transmission tower. So that is this will carry the transmission power, and it is like 132 kV line. So now again this transmission line is conducted a guard wire. This is known as guard wire, which protects the transmission tower from lightning and thunder. So now from this transmission tower, again it will come to step down. And each second it will step down up to 440 volt. Then this transmission line is given to the feeder line. This transmission line is now finally given to feeder line. So after this process, our conductor having a characteristic, that is, it consists of RLC circuit. So the network we connect through the conductor is in this pattern, that is RLC form. Our conductor, that is ALCI, it stands for aluminum concealed conductor for transmission line, that is aluminum concealed, steel reinforced. This type of conductor. Why we are choosing aluminum? Why not copper? Why not gold? Why not silver? Because aluminum having so many benefits, like it is lighter in weight. Number one, it is lighter in weight. Aluminum is very light as compared to copper and gold and silver. Another is, it is less cost. Number third is, it is having more resistivity. Number four is corona loss is less. So this is the advantage why we choose aluminum rather than copper. So first is, it is lighter in weight. As you know, aluminum is very light, and it is less cost. It is a most abundant material in the earth crust. So the availability is everywhere. It is having more resistivity. Means, as you know, resistivity. Somebody asked me why the resistivity. If the resistivity is more, then the losses will be more. But no. Why? I will explain the concept. Since we know, we will explain it in like that. Rho AL into L by A is equal to rho CU L by AC, which is greater than 1. From this relation, we find that when we will cancel, then it will become rho AL is less than rho CU, which is finally we conclude that AAL is greater than AC. It means the area of cross section is more in aluminum than in copper. So if area is more, then you might know that we have already studied in EMT, electromagnetic theory. That is, if area is more, then radius will be more. So if radius will be more, then what happening? We are having electric field, that is electric field in line charging. So the formula is E vector is equal to rho L by 2 pi epsilon 0 into R. So it means if radius is more, then electric field will be less. So if radius will be more, then E will be less. If E will be less, then ionization will be less. So corona loss will be less. What is happening? Electric field is less. That means electric field of aluminum is less than electric field of copper. And this results that it cannot be proceed towards dielectric breakdown and insulation breakdown, and also it cannot proceed. The more important is corona factor. So what is corona means? This is the conductor. Suppose this is the conductor carrying current, and this conductor around that the electric field is creating. It is creating electric field by means of air. Why? Because air is the medium of insulator. So air consists of so many small atoms, and that atoms when emit or release electron, that is known as ionization, and that electron pair will make what corona factor. So finally we got that due to this resistivity is more. If resistivity is more, then naturally the corona occurs less, and there will be less power loss, and which will be feedback to our load line. Now we will discuss the types of rating. So number one is voltage rating. Number two is current rating. And finally, MVA rating, megavolt ampere rating. So in a transmission line, we are having three types of rating. First rating is our voltage rating. What do we mean by voltage rating? Voltage rating is nothing but the RMS line voltage in a transmission line. What do you mean by RMS line voltage? There is so many types of voltage we are having. Line to line voltage, line to phase voltage, phase to phase voltage. Always the line to line voltage is 440 volt, and phase to phase voltage is also 440 volt. As we know how to calculate the power, we are having power is equal to root 3 VL IL cos phi. Why it is root 3? Because it is three phase. So root 3 VL IL cos phi is line voltage, and IL is line current, and cos phi is our power factor. And always we are keeping cos phi. Cos phi means nothing but R by Z. So means always we are having cos phi less than equal to 1. Why? Because in order to keep the stability of the system, we must keep the power factor less than 1. So in a lagging power factor, it is always 0.8. Now it is current rating. Current rating is nothing but the RMS line to line current in a transmission line. So on the transmission line there is line to line voltage and also line to line current. But to keep in mind, we have to monitor both voltage drop and line current in a stable manner. If we will not monitor it properly, then there will be a power loss. So there is more power loss if we can't handle the line voltage rating and current rating. Next is MVA rating. This is what mega volt ampere rating. finally what we are having the power rating. So we must keep in mind that in order to have the stability and efficiently to keep more what efficiency in a transmission line, we have to manage these three. It is voltage rating, current rating, and ampere rating. And ampere rating is nothing but megavolt ampere rating. So now finally we will discuss we will get now distribution system. So what is distribution system? After reaching the transmission line, the power gets distributed among us, and we are the consumer. We are the consumer, so that we will consume power. So after transmission line, the power went to the distribution section, and this distribution section is nothing but the consumer and feeders of the society. So now I will discuss distribution system. It consists of both single phase, three phase, and parameters. So what are the parameters we discuss? First of all, we know that P will have maximum power when VSVR by X. So this is what source voltage and this is my receiving end voltage. So these two are the parameters, and X is the reactance. And where Pmax is inversely proportional to 1 by length, and this is nothing but length of conductor. Why? Because when the conductor line length is more, then reactance will be more. And if reactance will be more, then power loss will be more. So, in order to keep the Pmax in a constant and stability manner, we have to manage reactancy as per the length. So, length is always fixed. So, we have to vary the reactancy such that the power can't go to the loss side. So, in order to explain the transmission power, what are the types of transmission power? We are having first substation. What is substation? The energy when transferred from generating station to the distribution station. In between that, a substation exists. So, what is the work of substation? Where substation is kept, we have to step up the transformer, step up the voltage. If the generating voltage is 33 kV, then by doing so step up, we will make it 132 kV. So from 132 or 66 kV, 66 kV to 132 kV and more. So what is the now benefit of AC transmission line than DC transmission line? Now we will discuss what is the benefit of AC transmission line than DC transmission line. See, what we are now having the total power circuit and total consuming power, we all are having from AC transmission line. Why it is AC? Because due to some major factor. First factor is it is reliable and less cost than DC. And second factor is it doesn't have any insulation, but this transmission line is insulated. Why? Because if we are not insulated the DC, then it will become much heat. So DC line is always insulated, but AC line doesn't. And third one is it can transfer over and long lines. It can transfer long overhead lines. We can transfer the AC transmission line 500 kilometers, 600 kilometers, so very long. Now, what will be the circuit when we are transmitting the AC power? So, what should be the conducting medium and conducting circuit? It will look like this. Like this, if you view the conductor medium, then it will have network like this. R and C circuit means R, L and C, and this one ground. Next, it will also like this. So like this we are having the conducting network. Why? Because if anybody asks me, there is no capacitance in the conductor. No. Yes, absolutely right. But how the capacitance act? When the conductor medium having the gap between two conducting medium, it will act as a capacitor. So that medium is considered as capaciting circuit. And this one is our resistance circuit, this one is inductance circuit, this one is another resistance. So like that we will construct the transmission line. And another example is, very first example, we are having Hirakud Dam. So from there the line generates and we are step upping that line and we are getting so much distribution throughout our state. So like that, so many dams are there, so many reservoirs are there, so many power generation stations are there. So like that we are converting power to transmission line, and finally we are getting from distribution parameter. Next class we will discuss briefly about distribution of all these things. Thank you.